Hello Algebra students. Today we're going to be working with operations that involve radical expressions. But before we start into today's new lesson, let's work these review problems. So pause the video. I'm going to work them out, but I want you to work them on your own first and then check your work against my work. So pause the video. Thank you. Alright, at your own pace, you can pause this video and study my work on the review. I'm going to try to scroll down. It keeps jumping. Okay, there's number 6. And there are the worked out solutions. Now, let's move on into today's lesson called Operations with Radical Expressions. As you can see in our concept summary, we are going to have operations. We're going to be adding or subtracting, multiplying. We've already talked about dividing radicals. So let's look at the operation of addition. A on the square root of b plus c on the square root of b can be simplified by saying a plus c on the square root of b. In other words, you treat it as if it were like terms. So something that might be helpful is to think about like terms are similar to like radicals. Like terms or like radicals. So since we have square root of 3, square root of 3, I can add 4 plus 6, which is 10 square roots of 3. I have 12 square roots of 5. Somebody came along and took away 8 of my square roots of 5. I have 4 square roots of 5 left. Now they show you the reverse distributive property where you take out the 12 and the 8. But it's still the same math. 12 minus 8. You're doing that portion a lot of times in your head or on your calculator without writing it down. But these are called like radicals. You can add and subtract. Here you're going to multiply. You multiply the coefficients, the numbers in front, and then you multiply underneath the radical. So 3 times 5, those get multiplied. Then the 2 and the 7 are multiplied underneath the radical, leaving it underneath as 14. So the best way to learn how to swim is to get in the water. So let's get in here and try simplifying some of these problems. Do we have any like terms? I see 4 radical 2, 2 radical 2, and then I see a square root of 3 and a square root of 3. So let's combine our 4 radical 2 plus 2 radical 2, 4 plus 2, and those are both radical 2's. So that gives us a 6 radical 2. Then we have plus 8 radical 3. Where was I? 8 radical 3 minus 5. So 8 minus 5, all on the radical 3. So that subtracts and you keep the sign of the larger, so that's going to be 3 radical 3. And that is the best I can do. That's as simplified as I can write my final answer because they are not like terms. This is radical 2 and this is radical 3. All right, for example, B. I was trying to change my pen color. It doesn't want to let me. Here we go. First I have to simplify these because those are big radicals. And I know that that is 9 times 3. And that is 4 times 3. And that is 25 times 3. So I can lasso out the square root of 9, which is 3, and 6 times 3 is going to be 18. Here I can lasso out a 2, which will be 8 times 2. And here I can lasso out a 5, which will be 2 times 5. And they're all on the square root of 3. So, all right, so 6 times 3 is 18, square root of 3 plus 8 times 2 is 16, square root of 3 plus 2 times 5 is 10, square root of 3. Add them all up, and you end up with 44 on the square root of 3 as your final answer. 44. Okay, flip on over to the next page. So on the back, when you're adding and subtracting expressions with like radicals, you're going to combine the coefficients in front of the like radicals. So it's just like having x's and y's. You can add all your x's together and you can add all your y's together, but you can't combine x and y. So if your radicals, like in number 2 here, you have radical 2 and radical 11, you can't combine those. So I'm going to do 1 and 3 with you and leave 2 and 4 for you to try on your own. So 6 plus 2, that gives us 8 radical 5 minus 5 radical 5, and 8 minus 5 leaves us with 3 radical 5 as our simplified expression. These are already square root of 13, and 4 plus 3 is 7. But then you need to subtract 2, so you have 5 radical 13. Y'all can do this. Now 4 is going to be a little bit tricky because you have to break down the radicals, but I did that in example, the second example on the front side. So go back to that example if you need to. Let's talk about when we multiply radical expressions. Again, when you multiply, you're going to multiply the coefficients. So 4 times 2 is 8. And then underneath the radical sign, you're going to multiply the numbers under the radical. So 3 times 6. Now, before I go ahead and say 8 on the square root of 18, realize that you can keep breaking it down. 6 can be broken down as 3 times 2. And there's that whole idea of lassoing out a number twice. That means 3 squared, and the square root of 3 squared is 3. So 8 times 3 is going to give us our coefficient, and that's going to be 24 radical 2 once you get it all simplified. All right, I'll let you do number 3 on your own. Let's look at number 2 together. Here I have parentheses. I need to distribute 4 radical 2 times 3 radical 2 plus 4 radical 2 gets distributed over to 2 radical 6. So this becomes 12, and square root of 2 times square root of 2 is the square root of 4, which is 2, plus 4 times 2 is 8. The square root of 2 times the square root of 6 is the square root of 12, which is 4 times 2, not 4 times 2, 4 times 3, or you could leave it 2 times 6, which is 2 times 3. So that's how that one can break down and lasso out the square term. So that'll be times 2 outside. So our final answer for number 2 is 12 times 2 is 24 plus 16 radical 3. Don't forget, when you lasso it out, you need to mark them out so you know you've already put that number here. So 2 times 8 is 16 on the square root of 3. And because this term does not have a square root, that is as simplified as I can write that expression. I'm going to leave 4 for you on your own. Let's look at the geometry. Alright, for this geometry problem, they said find the area of a rectangle. And I know the area of a rectangle is length times width. And they said for this problem, the width is 3 radical 3 plus 5 radical 7. And the length is 4 radical 6 minus 2 radical 14. And it says find the area. So I'm looking for A. So it's going to be length 4 radical 6 minus 2 radical 14 times width, which is 3 radical 3 plus 5 radical 7. And here I'm going to have to do the FOIL method. The first term times the first term, then the outside terms, then the inside, then the last. So here we go. 4 radical 6 times 3 radical 3. 4 times 3 is 12. Radical 6 times 3 is 18, which is, we could leave it, we could break down 3 times 3 times 2 is 6 and 3, because the 6 is 2 times 3, and I already had a 3. Plus, because of this sign right here, 20 Radical 42, I can't break down 42. And this sign makes it negative. 2 times 3 is 6. Radical 14, which is 2 times 7, which doesn't break down. It's going to be another 42. And then negative times positive makes negative. 4 times 5 is 20. Radical, all right, so where was I? 14 and 7. 14 is 2 times 7 times the 7 that's underneath the radical with the 5. So again, you can go through and you can lasso out the numbers that are repeated. The 3 can come out and be brought out front. 42 doesn't break down here. I can bring out a 7. Okay, so when we simplify, our final answer looks like this. 3 times 12 is 36, radical 2. Maybe I should move up. Okay, 36 radical 2 plus, and these subtract 20, take away 6, square roots of 42, and you have a positive 14, square root of 42. And then you have negative, because the 7 times 20 is 140, minus, okay, let's leave that. We went ahead and combined those, but right here we'll make that 140 radical 2. And now we have like terms here and here, and that's going to subtract and give us a negative answer. So 14 radical 42 minus 34 radical 2, and that would be our final answer. All right, have a sunshiny, happy day.